I have here two polarized light filters commonly found in sunglasses. These, depending on how we angle them, will block a particular amount of light, blocking the most at 90 degrees. Now, watch me add a third filter halfway in between. What? How does more light go through? See, the universe is strange, so to understand it, we'll have to slip into the world of quantum physics. Let's imagine a photon of light not as a definite particle, but as a collection of probabilities passing through different filters. Very simply, the photon is in a quantum superposition. Whenever it hits a filter, it'll assume a new superposition based on its angle. Weirdly, the photon has both passed and not passed through the filter until it hits the camera. So, while the two filters block every photon, the extra filter adjusts the superpositions so that more make it through. But hold on, superposition explains this statistically, but can a particle actually be in this uncertain state? This, in a sense, was the great Bohr-Einstein debate over quantum physics. Niels Bohr and Albert Einstein both saw that the math of quantum mechanics works for describing the behavior of particles, but they disagreed on how to interpret it. To understand how, let's look at a phenomenon called entanglement. For simplicity's sake, think of a pair of entangled photons like identical twins. If you observe one passing through a filter at a certain angle, you know instantly that the other would as well, no matter how far apart. In a quantum world, as understood by Bohr, entangled particles share a single superposition. So, when a polarized filter changes the superposition of one photon, it also changes the others instantaneously. Meanwhile, Einstein didn't like this interpretation. Instead, he believed in local realism, a principle stating that particles shouldn't be able to influence each other faster than light, and that physical properties must always have a definite value. Therefore, as Einstein argued, when first entangled, the photons must, in some way we don't yet understand, agree on some unknowable hidden variables, which know precisely what filters the photons will pass through. Underneath Bohr's quantum world of uncertainty, Einstein imagined a definite world of hidden variables. But believe it or not, we now know he was wrong. This is thanks to a famous result called Bell's theorem, discovered by John Stuart Bell. It showed that quantum mechanics and local realism are incompatible. Imagine randomly tossing a bunch of entangled photons through these three filters. If the photons agreed on these predetermined hidden variables, each pair would fall into one of these 8 categories. As a result, the probability of a photon passing through filter A but not B, plus that of it passing through B and not C, must be at least as large as the probability of a pair passing through A but not C. Meanwhile, quantum physics gives us predictions that directly contradict this inequality. So, quantum physics and this hidden variable theory can't both be true. So you see, the universe is truly strange, as long as you're ready to look at it through the right lens.